This is a review of a new paper 2014 by Christopher Powers and his group at USC that is titled Patellofemoral Joint Stress During Weight-Bearing and Non-Weight-Bearing Quadriceps Exercises. Let's go to cut to the chase and look at these two diagrams that kind of set up their question. Essentially, they are looking at the difference between a variable resistance kind of exercise, and would be akin to somebody, a patient sitting with a ankle weight or a cuff weight of some kind, or a leg machine, and they have a weight here causing an external load, and then they start in 90 degrees of flexion and then extend the knee. What this diagram is illustrating is that the weight force stays the same and acts in the same direction throughout the range of motion. Essentially what this means is that the perpendicular distance to the knee joint center varies, and that makes the resistance or the moment of the external load vary throughout the motion. So we can see here's L1 is longest when the knee is straight. It gets a little smaller as the knee bends to 45 degrees, and then it's the least at 90 degrees of knee flexion. What this suggests then is the moment, or the quadriceps load, would increase as the knee goes from a 90 degree flex position to a fully extended position. If we contrast that with something like an isokinetic machine, where we're looking at having a constant load throughout the range of motion, a constant external load, the model would look something like this. So this is the person here, they're sitting on an isokinetic machine and they're kicking out against the isokinetic machine where the resistance is constant. And so in this case, the direction of the force is always perpendicular to the limb, not the weight. It's not a weight force. And so by doing this, we notice that now L1, L2, and L3 are constant throughout the motion, and so the actual resistance or moment from the external load is the same throughout the motion. And so they're different, so you have a different kind of loading. And so the question becomes, so we have those two conditions, and then the third condition is when someone performs a squatting activity. And what we can do is, this is during those different squatting, the variable weight condition where the person's kicking out, and then the isokinetic knee extension exercise, we can use a biomechanical model and take in the moment, the knee angle, the patellofemoral joint contact areas, quadriceps force, patellofemoral joint reaction force, quadriceps lever arm, the relationship between quadriceps force and patellofemoral joint reaction force, and we can use all that to calculate stress, patellofemoral joint stress, which we think would be connected or important for people with patellofemoral syndrome. So that's a fairly sophisticated model, and here is the output or results from applying that model to the three different exercises. So what we see here is plotted. We have joint stress plotted here on the y-axis. We have knee flexion angle on the x-axis. And we have three different lines representing each activity. And we can see that essentially the variable resistance or free weight kind of approach is in blue. We can see that patellofemoral joint stress starts highest at full knee extension and then decreases as the person flexes. And it shouldn't surprise us, because the moment our work of the quadriceps is decreasing, which would also then drive stress lower. Now, for a constant level of stress, that would be our resistance machine, something like a isokinetic machine, we see a little bit of a difference where we have high stresses at 0 degrees, but then we also see very high stresses kind of consistent throughout and almost equivalent at 90 degrees. And then we contrast that with a squatting activity and think about the squatting activity and how the external load would work is when you're fully upright or the knee is in 0, there's relatively little demand on the quadriceps, so joint stress is low. But then as you flex, your external load increases as you get to 90 degrees of knee flexion, which would be quite extreme for a squatting activity. The joint stress becomes quite high. So essentially, for exercise prescription, this relationship between stress and knee joint angle becomes important. So, for example, if you had a lot of patellofemoral joint pain, and you didn't want to aggravate the condition, if you were doing a open kind of chain or free weight approach to exercise, the safe ranges of motion would be from 45 to 90 degrees. If you were doing a weight-bearing squatting activity, the safe ranges of motions at the knee would be 0 to 45 degrees. So exactly opposite parts of the range of motion because of the different external loading conditions that are contributing to the stress. So this is an important and key graph to take into account when you're treating people with patellofemoral syndrome.